Thanks for joining us on this episode of the Lake Doctor Podcast. I'm Susie Light and my co-host, Dr. Nate Bosch, an official lake nerd.
Yes, that's right. I got my doctorate from the University of Michigan in limnology, which is the study of freshwater lakes. In today's episode, we're excited to have Dr. Stephen Jacquemin. He is a professor at the Lake Campus of Wright State University.
And we're going to learn the difference of Grand Lake St. Mary in Ohio and how that lake is different than the lakes in Kosciusko County. We're really excited about today's episode. The doctor is in. Stephen, welcome to the Lake Doctor Podcast. So today, Stephen Jacquemin is joining us. Tell us about your journey from the Midwest to Cuba and then back again to Grand Lake St. Mary's.
Well, first of all, thanks for inviting me. Thanks for having me and showing me around this beautiful campus, and it's a pleasure to be here. But my journey has taken me all over sort of the North American plate, always with a focus on better understanding aquatic resources. I ended up in Cuba, as you brought up, as an environmental science student. I studied and worked at the University of Havana in the Centro de Investigaciones Marinas, and did a lot of coral reef surveys. Did some work looking at not just basic coral reef surveys, but did a lot of work with trying to understand the trophic ecology of those systems, including some work with some of the big pelagic sharks that are out there.
So,
Cool.
you know, you may not know, but I'm not really a science nerd. I just get to hang
really?
out with Dr. Nate. And so you used a word I didn't understand,
Trophic.
Trophic.
That's a good
Trophic.
word.
Okay, it is a good word.
Would you explain that?
The word of the day. Trophic is an ecology term that refers to sort of a food web. So understanding, the base of that food web with primary production and sort of algae and plant life, and then echoing that up in terms of something eats that, and then something eats the something that eats that, and then something that eats the something that eats the something. And then you go up far enough and in that
And people
marine
eat fish.
system, people eat fish, or sharks eat fish. So I traveled around Cuba, mainly sort of staying around the Havana region. Studied at the university there for a period of time. Worked with the center as sort of a scientist, and then when that period was up, and I had sort of finished my environmental management certificate from them, came back to Ohio with a sort of renewed interest in freshwater resources, and so I moved from studying freshwater resources initially in my career, then continued my studies and developed some skills and studies in marine systems down there in the Caribbean, and then came back to the Great Lakes region, my home.
Super. Cool. So today we're going to talk about a couple of really interesting things to me, blue-green algae and wetlands.
Yeah.
So Dr. Nate, how did what's happening at Grand Lakes St. Mary's impact the work you're doing?
Yeah, so I can recall back, it's probably been over 10 years ago at this point, started to see in some research papers and even in some news broadcasts about what was going on in Grand Lake St. Mary's, probably even further back than that, maybe more 15, 20 years ago. And so I've been out there visiting you 3 times now. So I remember the first time also meeting with some DNR folks out there. And the echoing refrain that kept coming back was, hey, you guys don't want to get to this point where we are. You need to be proactive rather than reactive. And that has really rung true and has really helped us at the Lilly Center set our priorities on what we want to do. And so we've noticed some blue-green algae toxin issues in some of our lakes, but typically not to the same levels that have been seen on Grand Lake St. Mary's. And so we want to make sure we don't have that. in the relatively smaller amounts of blue-green algae that we do have in our lakes, we want to minimize that so as to minimize the risk of those toxins for people and pets in our community.
So, Stephen, how did Grand Lake St. Mary's become so unhealthy?
Yeah, so it's a long history. And we'll be here for hours discussing it, of course. But no, the Cliff Notes version is Grand Lake St. Mary's is a remnant from the canal era, going back to the 1830s. This was one of the first infrastructure projects in the state of Ohio, actually. But Grand Lake St. Mary's was constructed as a feeder canal or feeder reservoir to supply water for the middle parts of the canal. Middle as in the canal that we're talking about, the Miami-Erie Canal. It ran north-south from Cincinnati to Toledo. In the middle of that canal is the sort of central portion of the state. Grand Lake St. Mary's, as well as Indian Lake, as well as Lake Laramie, were constructed as canal lakes to sort of provide water for that system.
So they were man-made lakes, not natural lakes.
That's right. And as a function of that, in addition to the fact that they were sort of constructed in the 1830s, they were never dug very deep. None of these canal lakes were. So Grand Lake St. Mary's has an average depth of, maybe 5.5, 6 feet.
Oh.
So incredibly shallow, but surface area-wise, it's incredibly large. You can see it from space.
Mm-hmm. The largest inland lake in Ohio,
At one point,
right?
That's right. Yeah, it was. It was the largest. At one point, it was the largest human-constructed reservoir on Earth.
Oh, wow.
Not just Ohio.
Wow.
So it no longer has that title, but it's still it's a big system. But again, it's big in terms of surface area, not volume, which leads to your question about how did blue-green algae become a problem? And it has to do a little bit with the lake bathymetry. In other words, how the lake is shaped. It's incredibly large, but it's incredibly shallow, which means anything that goes into it doesn't really dilute very much. Mm-hmm. And so what could be going into it? Grand Lake St. Mary's is the other portion, the other piece of that story. Grand Lake St. Mary's is in a highly agricultural region. It's one of the most prolific and successful agricultural regions in the state of Ohio. It ranks very highly in corn and soybeans, as well as livestock, and particularly poultry, dairy, and swine. And those important sort of agronomic functions that we all need to survive, and they also have nutrient runoff as a product of those activities. And over the course of time, those nutrients from a heavily agricultural region gradually run off the landscape, and they accumulate somewhere. And in the case of Grand Lake, all sort of roads or streams, so to speak, lead to that system. And so over the course of over a century, those nutrients from these activities on the landscape that we all need to survive, those nutrients built up, and they have to go somewhere. And blue-green algae are the things that pick those up.
And also with that shallow depth, you're going to have sunlight that gets in a large portion of the water column as well, right? So if you have some of our deeper lakes here in Kosciusko County, 80 feet deep, 120 feet deep, a large portion of that volume of the water, sunlight can't get down that deep. And so whereas in Grand Lake St. Mary's, there's a large proportion of what we'd call the water column that is sunlit, which then provides both the sunlight, the nutrients that those algae need, and then they grow quite prolifically, and some of them then will produce toxin levels. And so
absolutely right.
To be unhealthy, then you've got lots of algae producing lots of toxins.
Yep. And not just, certain algae are very healthy and very good and natural for lakes, but in this case, when you have systems that are, in climates like we have here in the Midwest, that are enriched by excess nutrients through a process called eutrophication.
Oh, we've talked about that word
Yes,
already.
I remember really?
that.
Yes, good work bringing that up.
Hey, I'm a long-time listener, first-time caller. But no, that sort of creates this recipe for just excess blue-green algae growth. Cyanobacteria is another name for these. Right. And Grand Lake St. Mary's is not the only reservoir or freshwater system that suffers from eutrophication and ultimately harmful algal blooms, but it has become almost one of the poster children for it, in part because it's such a large system. In addition, because of how severe at one point in time the bloom and the nutrient levels were.
So it was impacting human health because of the severity of the problem.
Yeah, so depending on what metric you want to define with human health, it was certainly impacting the region. When we look at the severity of that bloom, or the severity of the problem at Grand Lake St. Mary's, at one point in time, Grand Lake St. Mary's ranked in the 99th percentile for harmful algal bloom toxins that Nate, you were just talking about. So the 99th percentile is in the complete opposite end of the spectrum you want to be at. At one point, it ranked up there when you surveyed sort of public water source intake lakes nationwide. At one point in time, the nutrient concentrations, that is to say the nitrogen and phosphorus that runs off the landscape, goes into the streams, goes into the lake, at one point in time, that was in close to the 75th percentile from a concentration standpoint in another federal nationwide survey. And so you had all of these sort of recipes and catalysts for something big happening. And about 15, 20 years ago, everybody took notice, and we had one of the larger harmful algal blooms that's been recorded.
And that then leads, it's not only then a human health concern, but then it starts to trickle into, well, people don't want to buy a house around the lake, and tourists stop coming to the lake. And so
Strong
I remember
economic impact.
Yes, I remember
That's
first visit there, kind of being around in the area, and you making the comment that at times these towns around the lake, it's so big, there's multiple towns around the lake, things would be booming and there'd be so many people here, but now it's a lot less than it once was because there's not as many tourists who want to come. And even home prices, I talked to some of the realtors around the lake, and some of them quoted things like 50% decrease in home values for some of those homes around the lake. So these environmental concerns lead to human health, which leads to the economics of these problems.
And that's sort of going back to 2008 to 2010, 2015, right in there. So we're talking about, this is the condition 10 years ago. Home prices had plummeted. The toxin and the bloom itself had reached such a level that it was, impacting daily life. It was impacting the economy.
So that's the problem. Tell us what you're doing work-wise for the solutions.
Hey, no, this is the best part. This is
Yes.
This is my favorite part.
Put on your cape. You got a
That's
Superman
my
cape.
No, so Grand Lake St. Mary's was, again, one of the poster children for the harmful effects of eutrophication, harmful algal blooms. You can't get around that. You can't dance around that. But the reality is, since that point in time, the tide, so to speak, has really begun to turn. And it's been a really exciting last 10 years at Grand Lake St. Mary's, because as awful as that period of time was, and as big of an impact as we all saw occur, it served as a catalyst for a whole myriad of positive changes in the watershed. And here we are 10 years later, and we can look and we can start to see the progress and the impact of those positive changes around the watershed. And those statistics I espoused a moment ago about being on the wrong end of the spectrum, Grand Lake St. Mary's is no longer there. It's no longer at the wrong end of the spectrum. It's not completely on the other end, but
You're getting there.
slowly we're getting there.
So what are the steps you're doing to get there?
It's harmful algal blooms are not just at Grand Lake; they're all over the world. Fortunately, they're not all that difficult to understand. Yes, there's a lot of mechanisms. There's a lot of things that go into what influences a bloom and what changes this and what changes that and what changes the rate at which toxins get released, et cetera, et cetera. But at the end of the day, it's nutrients. It's nitrogen, it's phosphorus stimulating the bloom activity and the toxin production. And so when you're trying to solve this problem, that's it. It's nutrient reductions. And that comes from just a lot of hard conservation work around the watershed that in the Grand Lake region, a whole wealth of folks have been involved with over the last decade plus. And those efforts, again, have started to bear fruit, and water quality has responded.
So some of the partners that you've been working with, I would imagine, are the ag community, since Grand Lake St. Mary's is surrounded by agriculture. How is that? How are you constructing the partnerships with your residents, your neighbors, your agriculture community?
Yeah, it takes a community to sort of do this. It takes everybody, lots of people, all rowing in the same direction to, begin to diagnose a problem like this and begin to affect positive change. And I'm fortunate because I get to be the one sitting here, but by no means is it a one-person show. I mean, there's hundreds of people involved, many of which are extremely active in these conservation efforts. You mentioned the agricultural producers. Since that period of time, there have been a huge number of agricultural producers that have really stepped up in the watershed and are leading the way. They're models of modern, more environmentally friendly agriculture. Some of the things that have been done on an agronomic scale by some of our great producers, all of our producers have to have nutrient management plans, which means they test their soils to see what nutrients are actually needed, and then they apply just that, not an excess of that, just that. They have also mitigated nutrient application during particularly problematic times of runoff.
So if it's raining a lot,
if it's
not
raining,
fertilizing a lot,
or if it's snow or frozen ground, which in Grand Lake St. Mary's actually means, between December 15th and March 1st, there's no application of nutrients. And so you've got manure management, you've got nutrient management. In addition, there's been a whole host of best management practices incorporated in the watershed. Lots of tile control structures in the fields to try and slow down how much subsurface runoff is coming from the tiles. There's also a whole bevy of cover crops, as well as riparian zones, as well as even some new and experimental conservation practices that we've been fortunate enough at the university where I'm at to been involved with testing their efficacies, but things like saturated buffers and some advanced waterways.
Yeah, and we've had some of those conversations already on this podcast series. I can remember talking to Ben, came on with precision agriculture, talking about some of the nutrient management and some of the technology then that can help some of the things that Stephen was just talking about. So I know some of those things are going on already in our area here as well.
And what we've learned, and I'm sure that you've experienced this, that agriculture wants to be good stewards of what they've been entrusted with when it comes to land. And so helping them understand how they can save money, how they can do better.
We've noticed that misconception in our community, and I wonder about if it's the same in Ohio. I would suspect it would be, where you have those from maybe a lake perspective or an environmental perspective, wanting to sort of point the finger of blame at the agricultural producer. And when you start to dig through some of that, you see that the agricultural producer does not want to see good topsoil eroding from his or her farm, or see expensive chemicals like fertilizers or pesticides running off his or her farm, because that's wasted expense that was paid, just like the lake property owner doesn't want to see those things come into his or her lake, right? So
That's
when
right.
we look at it, we see we have the same goals, and so we've really enjoyed kind of creating partnerships and collaborative sort of interchanges rather than sort of pointing the finger and butting heads. And so I suspect you've seen that in your area as well.
Oh, absolutely. Nobody wants to be part of the problem. But it does take good communication to establish those relationships. And you mentioned, the potential for miscommunications and even at times fiery relationships. And there in the early days when the bloom really sort of exploded, there was a lot of, it was almost like a town versus farm kind of dynamic, and that wasn't productive. That wasn't the way to sort of do things. And the agricultural community, again, to their credit, they really stepped up and began implementing these practices. And to be clear, like, these practices were funded through different tax dollars and different grant programs and things like that, but they were participants in the process, part of the solution. And it was those sorts of actions that sort of mended some fences, so to speak, and got everybody to the same table. Whereas, once that first happened, there was very much two tables.
Yeah. So I imagine when you get ready to build a man-made lake, you dig a hole, and you probably don't pay a lot of attention to what's happening between the hole with water and the land. And so you might be missing something called the wetlands.
Well, maybe, yeah, that's possible.
So might you talk about what you're doing at Grand Lake St. Mary's when it comes to my favorite topic, wetlands?
Hey, your favorite too. That's great. No, so Grand Lake St. Mary's, you mentioned, it being dug. Funnily enough, it's not a word. Funnily enough, it wasn't really dug, right? So this is the 1830s, so you're not bringing in a lot of heavy modern equipment. It doesn't exist yet, and even if it did, you can't get it to that part of Ohio at the time. And so the lake wasn't dug so much as it was constructed by building embankments on the far east and far west side. And they built these embankments on an existing wetland, an existing depression, and then the streams that used to sort of flow out were now embanked. And so it wasn't like anybody went into the middle of the lake and
they trapped the water.
Dug it. It was just more like move some dirt to I'm minimizing, but move a lot of dirt to the sides, to the east and west sides. And that sort of finished off the natural basin. And there wasn't a lot of thought to the natural habitat in the rest of the watershed because, in the 1830s, the focus was truly on that infrastructure project to try and connect a shipping route between Cincinnati and Toledo. That was an important part of Ohio's, and Indiana's not far off of the strategy. They're involved. You guys are in on this too, because there was a canal spur that connected from Indiana over to
Erie Canal, right?
The Miami Erie Canal. That's right.
Yeah.
So the goal was to sort of improve economies and allow the shipments of goods, especially from the interior of the state, which was isolated at that time, to the exterior, And so wasn't a lot of thought to the natural habitat. And so if we think about what was in Grand Lake, we can go back, before any of this happened. And if you look at the original land surveys of Grand Lake St. Mary's watershed, it was a mixture of forest, prairie, and wetland habitat. And about a third, maybe a little bit more, of the entire watershed was actually natural wetland habitat.
Wow.
And so when this lake was constructed, it wasn't like that destroyed the wetlands. Quite the contrary. Grand Lake is technically one big wetland. It's the sort of activities on the landscape that take place in the centuries after, in the century after. And Grand Lake St. Mary's watershed has incredibly rich soils that are perfect for agriculture, and so that's the predominant land use in the region. And so over time, forests were deforested, prairies were sort of farmed, and wetlands were drained.
Sounds familiar.
Yeah, I was just
Hello,
going to say
Kosciusko
that.
County.
That doesn't sound all too different from Kosciusko County here in northern Indiana.
We used to be oak savannas, we've learned.
You did.
Yeah, and a lot of wetlands as well, and we've lost a lot, but Kosciusko, as compared to other parts of the state of Indiana, still retains a lot of wetlands as well, but we need more. So last time, I mentioned earlier that I've been out to visit you 3 times there, and the last time we did some walking around some of the constructed wetlands that you guys have worked on, and that was really inspirational for me, was seeing these areas that maybe used to be an agricultural field and lots of dirt being moved around to create a wetland.
Yeah.
And so talk a little bit about, I remember you telling us about how many acres of wetlands you guys have constructed, and then also how that's reduced nutrient inputs by certain percentages into Grand Lake St. Mary's. So tell us a little bit about that.
Yeah, I'd love to. It's so we talked about that historical land survey and how much of the watershed was wetland at one point in time. If you look at subsequent land surveys, especially the ones that took place in the late 1990s, the number of wetlands, the watershed starts at, say, 33 to 35% wetland. By the late 90s, the number was around 0.25%.
Wow. Was that due to housing developments?
A little bit of housing. But for the most part, it was draining of the wetlands. And in order to have productive, farmland and crops, you have to drain, the landscape. So you put in tiles, subsurface drainage.
And as we've talked about for wetlands on this podcast, wetlands often have that mucky, dark, organic, rich soil, which is really good for agriculture if you can get the water out of the area.
Yes.
Yeah.
And the best way to get water out of a wetland is with continuous subsurface drainage. And this area,
that's a tile.
That's a tile.
Okay.
That's right. And this area of Indiana, as well as Northwest Ohio, historically speaking, it was, predominantly wetland. And if you look at tile and you look at the distribution of that around the Midwest, really around the United States, the highest concentration of subsurface tile per square mile is right in this neck of the woods. It's right in Northwest Ohio, Northeast Indiana. Like that's where it's at. And so we've been very fortunate over the last 15 years or so in response to this problem of excess nutrients. We've been very fortunate as a community and as a watershed to be able to restore a lot of that natural habitat. And so I mentioned by the late 90s, the number of wetlands had gone down to 0.25% of the watershed. Very proud to say that today that number is around 2.5+% and climbing and growing. And these are intentional conservation efforts to restore natural habitats. Wetlands are, a great long-term sustainable solution for improving water quality, one aspect of which happens to be nutrient loading that can fuel harmful algal blooms.
Yeah, and you had said as well, stated a little different way when we were there visiting, you were talking about how I thought maybe it was 20% of all of the water that goes into Grand Lake St. Mary's now passes through a wetland or has the opportunity to pass through a wetland. Maybe it was 10% and you're going towards 20. I don't remember exactly the percentages.
Yeah.
But that was another percentage that I thought was quite important.
No, it is. And you're close there. The goal is to be able to filter all of the water that goes into Grand Lake St. Mary's. That's one of the sort of watershed conservation goals. And in order to filter water out of nature, you need, nature's water filters. You need wetlands to do that. We're up to about 2.5% wetlands. And the goal is not to get back to pre-colonial 1700s estimates. That's not the goal. That's not a realistic goal. The goal would be to get somewhere in the ballpark of around 7 to 10%, probably closer to 7% of the watershed as a wetland. So we are making measurable progress towards that. And the streams that do have wetlands in Grand Lake St. Mary's, of which there's a whole bunch of them, many of these wetlands are able to process close to 15% of every gallon in that stream, or the equivalent of every gallon in that stream. Being able to process this much water has been an incredible thing to see, just because of what they're capable of doing, and that's kind of where the science and the monitoring comes in. And we've been fortunate to be able to keep an eye on these systems and be able to document not just how much water goes through these wetlands on its way to the lake, but what the wetlands are actually doing as they function towards nutrient mitigation.
I want to make sure our viewers and listeners catch that. So you've been throwing out some different percentages. One was the percentage of the land. So you have a watershed area, a drainage area that drains into the lake.
That's right.
And of that land area, you want to have 7 to 10% of that land as wetland.
That's right.
Compared to other sort of upland sort of ecosystems.
Or other, yes, that's correct. Yep.
But then you also said that you want to have all of the water or 100% of the water filtered. So you can filter 100% of the water going into Grand Lake St. Mary's by having maybe only 10% of the land in
Sure.
wetland, right?
Yep.
Okay,
Yep.
so you don't have to get to 100% wetland.
No. You don't have to
You
get to
can,
100%.
it's where those wetlands are.
It's about situation,
Yes.
where they're located, and it's about how those wetlands process the actual water. Because again, we kind of say like it's great when the water passes through it, but just because the water passes through a wetland doesn't necessarily mean that it comes out perfect.
Mm-hmm.
You know, if water only spends a millisecond in the wetland, how could the wetland possibly
Right.
do anything? So this is getting to your point, Nate, is about the design of the wetland matters, where that wetland is situated matters, and brings up a whole host of topics of we like wetlands. How do we even go about it? How do we design it? How do we build one?
Yeah, that's what I want to know. How did
Is
you
it
build
really?
one? Yes, because Nate mentioned you were pushing dirt around, but I imagine, there's more to it than that. I know there is. So, like designing it and then planning it and then planting it.
Yeah, all the things. So turns out a wetland needs three things to be a wetland, right? It needs appropriate hydrology, it needs appropriate soils, and it needs appropriate plants. But when you really look at those three things that make a wetland, plants, water, and dirt, when you look at those three things, it's really hydrology is the overriding thing. If you can get the water to an area and get it to hold, then the soils will become wetland soils. They'll become anoxic. That means a soil without oxygen. It's an important part of being a wetland. And they'll become increasingly organic as plant material grows, lives, dies, decompose, and sort of settles back in. And then the plants that are in a wetland are hydric plants. That's hydric as in those are plants that are
Love water.
they love water. They can't get enough of it,
Mm-hmm.
and they're specifically adapted for. They have all these amazing adaptations that these lineages of plants have developed over time.
Deep roots.
Oh my gosh, just amazing root systems. The amazing ability to pull oxygen from places that a terrestrial plant would never be able to sort of pull oxygen from, and they propagate. Successfully
Reproduce.
in these. Yes, absolutely. Yeah. And so there's all these amazing things, but you got to get the hydrology right first. That's kind of the master of the trifecta of things you need to make a wetland. And,
Yeah, I remember seeing one of the constructed wetlands where the water comes in from the stream, and there's first some sort of a settling area where the water slows down. So in a stream, as the water is rapidly flowing, it entrains sediment particles. That's why sometimes our streams can look like chocolate milk after a big rain, because flowing water can hold sediment as it's flowing downstream. Whereas when it comes into the wetland, there's a settling pool at the beginning, so the water slows down, which means it can't carry the sediment anymore, and so it drops out. So that's one of the first stages of the water being cleaned. And then after that settling pool area, there's a whole channel of plants where the water sort of meanders through the wetland. Those plants are all absorbing more nutrients, and then it exits back into the stream cleaner than when it came in.
That's exactly right. That's, the wetlands that have been built over the last decade in Grand Lake are restored wetlands. They're engineered wetlands, which means they are designed specifically to remove nitrogen and phosphorus. And again, I get to be the fortunate one on this podcast today, but there's so many people that I work with, in particular, a professional engineer, Teresa Dirksen, has been phenomenal in helping design nearly every wetland in the watershed, and helping to sort of work out and suss out the details of what design elements make a wetland most effective for improving water quality. And as Nate said, our wetlands are really designed, no matter where they're at in the watershed, we design them so that water comes in, we settle out heavy particles first, and then the wetland becomes increasingly shallow and allow a combination of microbes and plants to do the things that they do, take up the phosphorus, denitrify the nitrogen, and then the water comes out the other end with less N, less P, and less TSS, less total suspended sediment. And from there, we can gradually affect small amounts of change that over time build. When you echo that year after year, wetland after wetland, you get more and more progress.
And it was really impressive to me also to see how you're doing monitoring where the water comes in and where the water goes out. So you know how effective that wetland is at any time of the year. And you can actually tinker with how much flow is going through that wetland to optimize the most uptake of nitrogen and phosphorus. So it's a sort of hands-on approach where there's always adjustments being made to that wetland to maximize its effectiveness, which I think is really cool.
Absolutely. I work with some great people at the Wright State Lake campus, the regional campus where I'm at, some phenomenal undergraduates that go out week after week, rain or shine, ice or otherwise. They're out there and they're grabbing samples, and we bring those samples back on a weekly basis to the lab, and we get a sense of what the stream is looking like and then what the wetland outfall is looking like. And in some of these systems, we can actually control how much water goes in. And so if we see that a wetland is, removing 99% of all of the nutrients and all the sediment, that's a great thing, and we love to see it. But we'll often turn the pump rate up because, it's almost maxed out, so we'll want to process more water. The more water you can process with a wetland, the greater load reduction. Load, of course, is the quantity of how much harmful substance. It could be nitrogen, could be phosphorus, could be dirt, could be anything. But the overall reduction of load is going to be tied to how much water you're processing. It's great if a wetland cleans water, but if it only cleans a gallon a day, that's not necessarily going to move the needle on a water quality problem. You need it to clean, more than a gallon. You need, millions of those gallons, depending on what system you're in. And so we try to optimize how much water goes through and balance our nutrient reduction efficiencies with quantity or volume of water to try and achieve the maximum amount of load reduction.
So I hear something in common that you guys have.
Mm-hmm.
You're both working with students
Mm-hmm.
who are actually doing like some of the hands-on work
Yeah.
that hopefully will become people like Teresa, your engineer who's constructing wetlands. Nate, tell us about the students that you're working with and how they're monitoring things.
Yeah, so we're just moving into the wetland space as an organization, which is part of the
Welcome.
reason having
The more the merrier.
on the podcast and part of our new Lake RX project, which we're working on. We've, though, for years had students involved in lake sampling, where they're out on volunteer boat captain boats throughout our county every week during the summertime, taking many of the same samples that we're just talking about for wetlands, the nitrogen and phosphorus, different forms of each of those, and then bringing those back to the laboratory and looking at algae and toxins and those sorts of things. But also our students are out sampling stream locations. We have lots of stream sampling locations around our county that we do internally for our own research programs as well as for other partner groups that we have in the area as well. And so us adding in monitoring of wetlands would be a natural next step for us as an organization and something that we're really excited about, because with that Lake RX program that we're doing, where we want to develop prescriptions for different lakes and how do we reduce those nutrients coming into the lake, we think wetlands are going to be a key part of reducing nutrients coming into our lakes. And so in order to optimize that reduction, as Stephen's just been talking about, we need to know what's going into the wetland and what's leaving the wetland so that we can change flow rates or change the wetland design or change plants that are in the wetland. If we don't measure it, we don't know really what's going on and how they might be helping.
So I want our listeners to really understand wetlands are important because
they're filters.
That's
as,
right.
As
They're
you just said.
filters?
So they're
Oh my gosh.
they're pulling nutrients out. The other thing that I was really impressed with when we were walking around the wetlands is they are amazing ecosystems in and of themselves.
An incredible amount of wildlife habitat.
Yeah, so we're constructing them with this purpose in mind of reducing nutrients from going into our lakes and improve our lakes and the people who enjoy those lakes, their lives. But the wetland has the wildlife, the birds and the mammals and the amphibians and such that are coming into that space. And you guys have some amazing walking trails around your wetlands, which was really cool to experience. And so people from the community come and are able to walk those trails and be out in nature at the same time as this wetland is doing some really important work.
Yeah, and it's not just, as you said, it's not just the nitrogen and phosphorus. That's the engineered intent, right? But as a natural consequence of having a beautiful outdoor space, you've got an opportunity for public recreation, and we've leveraged these systems to have walking trails. But they don't just do that. They also help to store floodwaters, preventing downstream property damage. They also help to recharge groundwater. And depending on where you are, an aquifer can become taxed, or an aquifer as in the underground region where drinking water is sometimes pulled from. Sometimes those can become taxed or overpulled, so this can help recharge. And when we look at all of these different benefits of wetlands, it's just an incredible asset to be able to restore them. And when we think about wetlands being engineered for nutrient mitigation and for improving water quality, one thing that sometimes comes up is, can that wetland ever become a source for nutrients? Like, I understand that it takes in nutrients, and okay, I get it. You just built this wetland and it's 4 or 5 years old or 6 years old, and it's taking in nutrients. But is there ever a time when it could turn around and maybe spit out nutrients and become a problem? Be a problem, yeah. Has anyone ever seen that? And the answer to that is, yeah, people have seen that with wetlands. And so the question should become like, well, what makes this wetland over here in Grand Lake different than other wetlands? What makes it sustainable, right? Because we want long-term, sustainable, natural solutions for nutrient mitigation. We don't want short-term pops of chemicals or something that's not sustainable. We want this to be around for future generations, and we want the problem to be solved for a very long time, not just in the immediate aftermath.
We've talked about that as holistic stewardship on this podcast.
Yeah.
I'm going to guess it's monitoring.
Well, monitoring is going to give you a sense of what the wetland's actually doing.
Okay.
And the monitoring, it informs decision making. It's so critical. Unfortunately, it's also one of the things that, like, week after week after week, it can be, tedious isn't the right word, but it can become routine. And sometimes routine things are viewed as less exciting, but it's actually quite exciting, you see. So it's that monitoring, though.
Another lake nerd.
That's right. It's the most exciting. No, it helps us understand what the wetland is actually doing, and if it's becoming a source. And we've actually had one of our wetland systems, a couple of our wetland systems that have been operational for close to 10 years now. We have seen there are periods of time when they've started to become a source. And so you wouldn't know that unless you had monitoring. Now, the solution, and there might be a variety of solutions out there for this, but what we had found was that those initial settling pools that we described, those fill up over time. And so what can you do? Well, we dug them to begin with, so just redig them. And that's what we did. And we found through monitoring that it reset the system in a very positive, productive way.
That's great.
Nate, how's the work that's being done at Grand Lake St. Mary really informing the direction that the Lilly Center's taking?
Yeah, well, we see that there's the possibility for measurable change, which I think is really exciting, right? You guys not only have seen in these wetlands, as we've just been talking about, where there's less nutrients leaving the wetland than what's coming in, but you're also seeing in the lake itself, you're seeing nutrient levels come down, you're seeing algae populations come down, you're seeing algae toxin levels come down, all as a result of all this work that's being done on the land. And with our Lake RX program, we have categorized solutions on the land, solutions in the water, solutions in the community. So the solutions on the land is what we're talking about right now in this episode. And so it's exciting for us to see the success you're having, and we want to build on that here in our own area and take some of the best practices that you guys have developed and you've learned and the partnerships that you have established, and we want to transport those here and get those same things set up here in our community to see that same sort of measurable change in our lakes.
It'd be amazing to see that built here.
Yeah.
Be able to, come back in 5-10 years and see the progress. These wetlands are so critical to long-term, holistic, sustainable solutions for environmental quality. And when we really look at them, one of the reasons that I find that they're so incredible is just how effective they are on such a small scale. When you look out across a 100-acre wetland, like, it can seem enormous or expansive, but the reality is, we've got a wetland that sits on 0.2% of the watershed. 0.2% of the watershed is wetland, and yet it processes 15% of every drop of water that drains across it. Wow. Something sits on 0.2%, and it's processing 15% of the water. Like, we're talking about, talk about fighting outside of your weight class.
Two orders of magnitude difference.
It's amazing. So is every wetland capable? No, of course, every wetland's not going to repeat that. Maybe there's a better one, but not every wetland's going to be perfect. Not every wetland's going to do that every single year. But the reality is, it becomes a sort of case study or a lightning rod to say, hey, these can be part of the solution. And unfortunately, across the United States, we've lost the majority of our wetlands. In states like Ohio, if you look at the historical land survey data, the state of Ohio has lost, or had lost, close to 90%. It's just an extraordinary amount of the sort of relative percentage of wetland habitat. And if these systems are acting as nature's kidneys, if they're acting as natural water filters, we need to put some of these back, because we've got a problem on our hands, not just in Ohio, not just in Indiana, but throw a dart at the globe. We got a problem with water quality, and these are not the panacea. They're not perfection in every single way, but they're part of long-term sustainable solutions.
So we're really excited. Stephen's agreed to serve on a wetland committee that we have here at the Lilly Center for our Lake RX program. Other Lake Doctor podcast guests like Scott Fetters, who talked about wetlands, Landon Vine as well, they've agreed to be on this committee. So we're developing this group of folks that know what it takes and know how to help wetlands be part of the solution for cleaner lakes in the future. So I'm so excited about what this is moving us into.
I think the bottom line is data informs us.
Right.
And wetlands are important because they impact the environment, which has an effect on human health.
Right.
So it's all of us.
Right.
Right? Like we always say, everybody lives on a watershed.
Yes, and Stephen said it many times in this episode that it's sustainable and long-term. A lot of times in environmental circles, there's different proposed solutions that are sort of short-term, nearsighted, maybe even have unintended consequences, whereas wetlands are one of those things that is a long-term, sustainable, holistic solution to some of the problems. That wetland is going to be there. It might take some maintenance, as you said, but it's going to be there and continue to help our water for the future.
I bet when they were changing the embankments of Grand Lake St. Mary's, you notice I didn't say digging a hole, that they didn't realize the consequences of their action at the time, because that was in the 1800s, right?
That's right.
So who would have known?
That's right. Yeah, and even more recently than that, who would have known? It takes a long time for nutrients to build up, but when they do, when a watershed reaches that critical moment, that tipping point, it can be drastic and it can be extraordinary in the negative sense. And that's what Grand Lake St. Mary's experienced. And that's what's been so amazing to see Not completely reversed, of course. Like it would be, foolish to say that Grand Lake is fixed or Grand Lake is perfect. It's not, but it's on the right trajectory, and it can serve as an educational model for other lakes seeking to improve. It can serve as a warning for don't get to this point. But that kind of stuff is, again, it's informed by the information and the data, and I can't imagine that every watershed sort of works out like Grand Lake has, but certainly it gives a place to try, it gives a place to start, and I think everybody that I work with in the local community and the great students that I work with at Wright State Lake Campus, very proud of the progress that's been made and eager and excited for what's next.
What's next?
More wetlands.
So
we're not quite there yet. I told you, we're not there yet.
Your dream for a thriving Grand Lake St. Mary's is?
We need some more natural habitat. We need more wetlands.
Stephen, thank you so much for being here today and sharing your expertise and helping us understand the importance of wetlands. And thanks for agreeing to work with Nate on that committee.
It's my pleasure.
We really appreciate you being here today.
Thanks for having me.
Thanks for listening to this episode of the Lake Doctor Podcast. You can share your thoughts or submit questions by leaving a comment or sending an email to lakes@grace.edu.
Listening to this podcast is just the first step to making your lake cleaner and healthier. Visit lakes.grace.edu for more information about our applied research and discover some tangible ways you can make a difference on your lake.
Please like and share this podcast. We'll see you next time. The doctor is in.